Welcome back to All This Math. This is Professor Parker. And for this lesson, we're going to do some GED math, which is really not GED math, but it just happens to be some math that you may encounter when you're, when you're preparing for the GED exam. I know the GED exam is like, it's the math portion is like difficult for a lot of people. I know a lot of people from my experience in teaching GED math prep. A lot of people pass all the other sections, but then the math is what holds people up. So that's why I wanted to do some videos, and I'm creating a playlist of GED math problems. So this is one of them. Even though you might see this in like a Algebra 1 class, Algebra 2 class, you might see this on a college algebra class, don't get caught up in names and titles is all I'm trying to say. So let's take a look. So our instructions are to solve, which means we want to figure out the value of x or the value of whatever the variable we have. In this case, we have x. We got 3x squared plus 2x minus 8 is equal to 0. First thing you want to think about is like, well, how I'm going to do it, right? Now, this is a quadratic. Now, why is it called a quadratic? Because the biggest exponent that you see is a 2. So this x has an exponent of 2. This x has an invisible exponent of 1 that you don't need to write. And this negative 8 is a constant. It doesn't have a variable attached to it. So your biggest exponent is a 2, so that means it's a quadratic. If it's a quadratic, you got a couple different options. If possible, you could factor it, right? Even though every expression is not factorable, but you could try to factor it and see what happens, right? You could use the quadratic formula, which works no matter what the expression looks like or what the equation looks like. You could complete the square, which also works no matter what the expression or the equation looks like. Even though if I had the choice, I probably would never use the completing the square method if I had the choice and if I was trying to be efficient and if I was taking a test, because that takes a little longer than the quadratic formula or than factoring, even though every equation can't be factored, but every equation can utilize the quadratic formula. And the quadratic formula is quicker than using the complete the square method. And also the quadratic formula actually was derived from completing the square method. One day, a long, long time ago, some mathematicians recognized that, every time we do this when we completing the square, it's the same outcome. I recognize the pattern. So with that pattern, they didn't create, but they wrote down what we know as the quadratic formula. So it's derived from the completing the square. Just a little bit of math trivia for you. Or the square root property. The fourth method is the square root property, which we cannot use with this because we have a linear term. This 2x is a linear term. We could use the square root property if we only had a quadratic and a constant. Quadratic, the x with the exponent of 2, and a constant, the number by itself. This is a linear term. So therefore, square root property is out. So we got a couple choices, quadratic formula, completing the square, or factoring. I'm going to tell you like this. I always try to factor first, no matter what. That's just me. That's how I get down. I always try to factor first. I might not be able to, but I'm going to find out, right? Because I know how to factor, and I like factoring. All right, now since this is a quadratic trinomial, why is it called a trinomial? Just same reason that a tricycle is called a tricycle. A tricycle got 3 wheels. A trinomial has 3 terms. 3x squared is 1, 2x is another, negative 8 is another. 3 terms, all right, trinomial. So if you have a quadratic trinomial, we can use a method that some people call reverse FOIL method. If you're familiar with FOIL method, you know that that's a way of expanding an expression. You multiply the first terms. When you have 2 binomials, binomial, bicycle, 2 wheels, 2 terms, right? Multiply the first terms, then multiply the outer terms, then multiply the inside terms, then multiply the last terms, right? According to their positioning in the problem. So let's see. We really doing experimentation right now, right? Math is very similar to science in that sense. Sometimes you have to experiment to find out if a method is going to work. It might work, it might not work, but we're going to find out. So let's do this. Let's first draw 2 sets of parentheses, right? 2 sets of parentheses that look like this, all right? How big should they be? How wide should the parentheses be? Wide enough to hold 2 terms in them and an operational symbol in between, a plus sign or a minus sign, all right? So that's a good width, that's a good width. Now, what's going to go inside the parentheses? Well, actually, this is what I would suggest you do, especially if you're not familiar with this method. I would draw 4 underlined blank spaces. So I would do this. I would do this, 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 and this. Boom. 1, 2, 3, 4. That's what I would do. All right. Now we're gonna put terms in these spaces. All right. Now what we're gonna have is we're gonna have factors of the first term and factors of the last term, and we want to situate them in such a way where when I do the FOIL method, after I put the terms in there, when I do the FOIL method and multiply all of this out, it should equal what I started with. It should equal what I started with. All right. Now, so this is like where it's like a game. It's like a puzzle, right? So 3x squared. So 3 is a prime number. So that makes things kind of easy for us in terms of the lead term. The lead term is 3x squared because it's in the lead, like the line leader in elementary school, right? Little kids be like fighting to be the line leader and all that, right? 3x squared is the lead term. So 3 is prime. So you only got two factors, 3 and 1. So, and it's an x squared. So one of them is going to be an x, the other one is going to be an x. So I could put a 3x right here and an x right here. Because 3x times x equals 3x squared, right? Now, this -8, that's got a few factors. We could have -8 and 1. We could have -4 and 2. Or the signs could flip. We could have +8 and -1. We could have +4 and -2. But we got to put them in these spaces and then do FOIL and see what happens. So this is like a trial and error method. Now, let me also say this. There are other methods that we could use in order to factor a trinomial, a quadratic trinomial. But because this is for the GED, I'm trying to get you to use the most efficient method. Especially if you're not really that familiar with algebra. All right. So I'm gonna try to put you on to like what I've been calling just this trial and error method. So let's take any two factors of -8. And you know what actually might help you, at least in terms of getting familiar with this method, like while you're like working through some problems, practicing leading up to the exam, just write down the pairs of factors of -8. So write -8 and 1, -4 and 2, and then +8 and -1, +4 and -2, right? Let's see what happens. So let's see what if I throw -8 right here, -8, and then +1 right here. And let's see what happens. So 3x times x, I know that's going to be 3x squared. I'm doing the FOIL method right now. FOIL as in FOIL. First, outer, inner, last. Like aluminum foil. Like, you go to the cookout, wrap your plate up in some aluminum foil, and you roll out. Tell everybody goodbye. Even though you know how black people be, it take forever to say goodbye. Take forever to leave. Right? You try to say goodbye, and it'd be like an hour later, you still saying goodbye. You know what I mean? But anyway, FOIL method, right? FOIL method. So first terms, 3x and x, that's 3x squared. The outer terms are the 3x and a 1, so that's 3x. The inner terms are -8 and x, so that's -8x. So really, we don't got to worry about the L for what we trying to do, because the L is going to work out no matter what, because it's going to be -8 times 1. It's going to be two factors of that number anyway. So we ain't really worried about it. What we worried about is the outers and the inners. The outers and the inners. We worried about these right here. The outers and the inners. That's all we care about for real when we doing this method. When you throw the numbers in there and, you're trying to figure out what's going to give you this middle term, this 2x right here. You're trying to get this 2x right here. So how do I get this 2x? 3x minus 8x, that ain't it. That's going to be -5x. So that's not going to work. So that means we got to switch some things up. Let's switch some numbers up. So -8 and 1 ain't going to work. But actually, what if we switch the position around? What if we put +1 right here and -8 over here? Let's see what happens. So the outers and the inners, right? 3x times -8. Oh, that definitely ain't gonna work. That's -24x. The inners is +x. Yeah, that definitely ain't gonna work. So that ain't gonna work. That's not gonna give you 2x, because we're trying to get 2x. We're trying to get a relationship or an arrangement that's gonna end up giving us 2x in the middle. All right, so that ain't no good. Let me do something else. Let's mess with this -4 and this 2. Let's see what happens. Let's see what happens with the -4 and the 2. So let's do -4 and +2. All right. Now, we only care about the outers and inners. Remember that, because the 3x times x is going to give us that regardless. The -4 times 2 is going to give us that regardless. So we care about the outers and the inners from FOIL, the outers and the inners. So what's the outermost terms? The 3x and the 2. 3x times 2 is 6x. Well, let me cross that out since that ain't no good. So 3x times 2 is 6x. The inner is negative 4 times x minus 4x. Uh-oh, we good. We good money now. We good money. We got 2x. That's what we wanted. That's what we wanted. We got what we wanted, right? So this arrangement is going to give us the factored form of this expression, right? We're not done yet though, because our job is to solve. If we were just factoring, then we'd be done. This would be our answer. This is the factored form of this expression right here. Now, the purpose of factoring is so that we can now solve a simpler equation, right? A linear equation, actually 2 of them, right? Because each factor is going to become its own equation. All right. So 3x minus 4 times x plus 2 is equal to 0. So the way we solve the equation is we take each of those factors, we make them equal to 0, and we solve for x. And it looks like this. So we're going to have 3x minus 4 equals 0. And then we're going to have x plus 2 equals 0. Where did this come from? Right here. This is my first factor. It becomes its own equation. X plus 2 is my other factor. It becomes its own equation. Then I solve for x. Solving for x means you get x by itself. That means I got to get rid of negative 4 and positive 3. So the opposite of, in order to get rid of things, I do opposite operations. Opposite of subtracting 4 is plus 4. Now, when we're doing algebra, it's all about balance. Ancient Kemet, Mayat, balance, all of that. So if I add 4 on the left side of the equal sign, I'll also have to add 4 on the right side of the equal sign. Cross that out. You got 3x is equal to 4. Now, how do I get rid of this 3? I do the opposite operation again, every time. Whenever you're trying to get rid of something, when you solve an equation, you do the opposite operation. But you got to know what the opposite operation is. But first, you got to know what the original operation is. 3x means 3 times x. That's multiplication. That's multiplication. So we say, okay, well, what's the opposite of multiplication? Division. So we're going to divide this by 3 to get rid of this 3, right? Because that's going to turn into a 1. 3 divided by 3 is 1. So that becomes 1x. 1x is just x. But again, balance, ancient Kemet, Mayat, all that. We got to divide by 3 on the right side also. So we got x equals 4/3. That's one of my answers. That's not the only answer, though. It's not the only solution. That's one of my solutions. X is 4/3, right? Because that will satisfy this equation. All right, now we go over here. Solve this one. X plus 2 equals 0. And in case you're wondering, like, why does it have 2 answers? It's got 2 answers because it's a quadratic, right? It's got something to do with, if we were to visualize it and see the graph of it, the graph of this would touch or cross the x-axis in 2 different places. 2 different places. And where it crosses the x-axis is right here, this number, and the number that we're about to figure out when we do this. So if I got x plus 2 equals 0, and I'm trying to get x by itself, I got to get rid of this 2. So what's the opposite of adding 2? Subtracting 2. So we're going to do minus 2 on the left side. Again, ancient Kemet, Mayat, balance. Subtract 2 on the right side. Boom, boom. Bring the x down. 0 minus 2 is negative 2. So these are our 2 solutions, right? These are the 2 numbers that make this a true statement. All right, and if we want to check our work, which we should always do, take each individual equation, not both of them at the same time, individually, not both, individually, and substitute them into the original equation and see if you get a true statement. Because math is all about finding the truth. That's what math is about. So if this gives us a true statement, if all of this over here calculated is equal to 0, then that means that we have found the truth. If it doesn't, then we haven't found the truth. It's somebody lying. All right, so we do 3 times 4/3 squared plus 2 times 4/3 minus 8 is equal to 0. Is that true? Let's use order of operations. 4/3 squared is going to be 16/9. Why is it 16/9? Because 4 squared is 4 times 4. That's 16. 3 squared is 3 times 3. That's 9. And then we got 2 times 4/3, which is 8/3. And then minus 8 is equal to 0. So then we got 3 times 16/9. So let's say 3, I'm going to cross cancel, right? Cross canceling is when you kind of simplify by doing diagonal division. So 3 and 9 have a common factor of 3. So I can divide each of these numbers. This 3 and this 9. 16 ain't really, don't got nothing to do with what I'm about to do right now. But this 3 and this 9, because they're diagonal from each other, we can reduce those numbers by dividing by their common factor, which is 3. So 3 divided by 3 is 1. So the 3 turns into a 1. 9 divided by 3 is 3. So the 9 turns into a 3. So now I got 1 times 16 over 3. So that's 16 over 3 plus 8 over 3 minus 8 equals 0. Now, we got to know something about adding fractions. We got to know how to add fractions, right? You can add the fractions when the denominators are the same. So I got this many thirds plus this many thirds. I got 16 of them plus 8 of them. 16 plus 8 is 24. So that's 24 thirds minus 8 is equal to 0. Now, 24 thirds, that looks like a division problem. 24 thirds is just 24 divided by 3, right? 24 divided by 3 is 8. So I got 8 minus 8 is equal to 0. That's a true statement. That's a true statement. So this answer is good. That's a true statement because 8 minus 8 is 0. All right? So we did all of that, and we proved that the left side is equal to 0. So that means it's a true statement. So that means our answer is good. Now let's check negative 2. I'm going to do it down here. So negative 2, I got 3 times negative 2 squared plus 2 times negative 2 minus 8 equals 0. Now, order of operations, negative 2 squared is 4. So that's 3 times 4. And then 2 times negative 2 I'm going to do. That's minus 4. And then that's minus 8. 3 times 4 is 12. 12 minus 4 minus 8 equals 0. Now, is this true? 12 minus 4 is 8, and 8 minus 8 is 0. So this is good too. So these are two good solutions. So this is what I showed you was how to factor a quadratic trinomial using trial and error using the factors of the last term. So this takes some practice. You're gonna have to do a bunch of problems like this. You're gonna have to do a bunch of problems like this. And the only way to know if it is factorable is if you tried every factor, right? If you tried every factor of the last term in each position, right? And it didn't work out. And it was impossible for you to find an arrangement where when you multiply these two binomials, they equal the original trinomial. All right. So it takes some work. Like it's labor intensive, but you gotta learn it, right? And as I said, there are some other methods of factoring quadratic trinomials. I have a playlist on the YouTube channel on All This Math that shows some of the other methods. Feel free to look through those if you want to. But in terms of like GED math, getting prepared for the GED exam, I want you to also, I'm thinking that like using the trial and error method with the factors is one of the most efficient ways to go about it. Even though it does seem labor intensive. All right, but also remember to always check your work. But when you're taking the exam, I wouldn't check my work when I'm taking the exam. When you get the answers, if it works out here, then I would just keep it moving because you don't have all day when you're taking the actual GED exam. All right. Now, also don't forget, once you factor it, you got to create your two equations. 3x minus 4 equals 0. X plus 2 equals 0. And then you got to solve them using the rules of algebra. All right. Inverse properties, inverse property of multiplication, inverse property of addition. You just do opposites. It's how you get rid of things and how you isolate the variable by itself. All right. So this is a good guide, but definitely go get some practice. You got to practice, right? Practice is the only way to get proficient. I think practice leads you to proficiency. Practice leads you to proficiency. Before I go, I want to shout out to Prairie View A&M University. This is their motto, quality without question, down in Texas, in Prairie View, Texas. And this school is important to me because this is a school that Jacob Carruthers, the late Dr. Jacob Carruthers, who was one of the founding members of ASCAC, the Association for the Study of Classical African Civilizations. He was one of the founding members. He taught, prior to being one of the founding members of ASCAC, he taught at Prairie View A&M University in Texas from 1960 to 1964. So he put some work in at this institution. So therefore, whenever I think of this institution, I think of that brother. I think of the books he wrote, Intellectual Warfare, Medu Neter, Irritated Genie, Essays on Ancient Egyptian Studies, What else did he write? He wrote an essay, a short essay called Science and Oppression. That's real dope. That's very important for us to think about living in Western society, because it deals with like how we utilize science and how we even approach science and think about it and conceptualize it. Also, I might be missing some other books that he wrote. I don't think I am. I might be. I know it's a dope essay that he wrote that's in, what's that joint? Too Much School and Too Little Education, edited by Malimu Shuje. He got an essay in there where he talks about Jacobus Capitan. So if you can, grab that. That's another book to grab too. Too Much Schooling, Too Little Education. That's a compilation. I like books like that because they like mixtapes. They like best of mixtapes. And Carruthers has an essay in there talking about this historical figure. Let's just say that we'll call him that, a historical figure from the continent of Africa named Jacobus Capitan. Again, the name of the book is Too Much Schooling, Too Little Education, edited by Malimu Shuje. So check him out. And again, this is a historically black college, and learn about historically black colleges and the value that they have and what they can contribute to our community in terms of uplift for us and the entire collective. All right. So like I said, go get some practice on solving quadratic equations that are quadratic because of the big two, because of the exponent 2, trinomials. All right, go get some practice, and I will catch up with you on the next video. All right, peace.